This is the second presentation in this group of short videos about climate change. In the first one, we analyzed several basic points about climate change. First, there is an overwhelming evidence about the increasing frequency of extreme climate events, climate disasters. There is also a warming of the temperature of the planet by about 1 centigrade degree over the pre-industrial levels. These anomalies are explained by the accumulation of greenhouse gases in the atmosphere, mostly carbon dioxide, methane, and nitrous oxide. These gases are mostly the result of, first, the combustion of fossil fuels, mostly oil, coal, and natural gas, and also the result of deforestation. So far, the mitigation policies that has been implemented in the last decades has been insufficient, has not been enough to reduce the speed of this very rapid process of accumulation of greenhouse gases. So the problem is not controlled yet. And secondly, is overwhelming the capacity of the planet for recovery. We analyzed it as well that climate change is not the only global environmental problem that needs to be addressed to preserve the civilization. The second problem is also very deep and very difficult to cope, which is a massive loss of biodiversity. In this presentation, we are going to analyze some evidence from paleoclimate, that means changes in climate that have been registered along with the natural history of the planet. The recent impacts of human activity on the climate, the inception of a new geological period, named the Anthropocene, and the lack of sustainability of the current paths. The first question that needs to be analyzed is quite simple. Has the climate been changing, or rather constant, in the recent geological history of the planet Earth? And the answer is that actually climate has been very unstable during all the natural history of the planet. We have here some empirical evidence about temperature changes during the Pleistocene period, which lasted about 2.5 million years. This is the most recent long geological period in our history. So here we have the record of temperatures of the planet during the last 800,000 years. This chart clearly demonstrated that actually the climate has been changing in a quite periodical way between two kind of very clear defined periods, which usually last for about 100,000 years. The glaciations and the interglacial periods in which the temperature has been going up. So the difference between the cold periods, the glaciations, we have several of them in the last 100,000 years. And the interglacial period is about 9 centigrade degrees. During the glaciation, snow and ice covered a very, very large part of the planet. The ice cover went down to the south of the Canadian border with the United States, and the northern part of the US in North America was covered by a very, very high mantle of ice, usually 1 kilometer high. This is the climate during the glaciation period, which was about 9 centigrade degrees lower than the current temperature of the planet. So the climate became very unstable. We have evidence about the reasons because it happened. It's a combination of some changes in the solar system, in the geometry of the orbit of the Earth in the planet, the Milankovitch cycles. We are not going to explain it in detail, and also changes in the composition of the atmosphere, particularly the concentration of greenhouse gases, as we analyzed it in the last presentation. Now we are going to concentrate in the closest period, which basically is the period in which Homo sapiens appeared, evolved in the planet. Human presence in planet Earth is very recently. Homo sapiens evolved about 200,000 years ago, maybe 250,000 years ago. In the mid of the glaciations and interglacial periods. So in most of the human presence in planet, actually humans have been affected by very deep changes in the climate, and climate become extremely unstable. Under these very difficult climatic conditions, human groups remained very small. Usually they were feeding by hunting and recollection of fruits or other vegetables. And most of these groups are small and nomadic, looking for food most of the time, and struggling with very adverse climatic conditions. Actually, once the last glaciation ended, which happened about 11,700 years ago, the Pleistocene ended, a new geological period named the Holocene began. This is a very recent event, and the particular feature of the Holocene has been climate stability. As we can see clearly in the chart, in this part, which has been highlighted in red. The most important change in humankind was the capacity to constitute sedentary societies and begin agricultural production. The origin of agriculture is the basis of our civilization. Agricultural production needs climate stability. That is why during the Holocene period, we have a combination of two very important changes. First, climate stability as a necessary condition. And second, the expansion of agricultural production, the inception of sedentary societies, and the expansion of human civilization, of human culture as we know it. It was possible only as a result of climate stability. Nevertheless, after, as we can see in this chart, and we have already seen in the last presentation, this stability is not going to last forever. Here we have, again, the several information about the temperature and also carbon dioxide concentrations during the last 800,000 years. And unfortunately, as we evidenced in the last presentation, we have a dramatic change that happened after the Industrial Revolution. That means in the last 250 years. So carbon emissions led to a huge increase in carbon dioxide concentrations that went up to above 400 parts per million, the highest level ever registered in the last 800,000 years. And at the same time, temperature is also going up very quickly. This is a dramatic change that has been concentrated in a very, very short period of time. So these changes are creating new conditions that can, as a result of that, can collapse the situation of climate stability that we have had in the past. Here we have some information about the Holocene period, the last about 12,000 years. And we can see here several different indicators about the human impact of human activity in the planet. For example, human population, energy use, the size of the global economy, GDP per capita. In all of them, we have seen a huge expansion in a very short period of time from the geological perspective, which is less than 3 centuries. So the question is the planet able to overcome the results of human impact, keeping the conditions that led to climate stability and the evolution of our civilization and agricultural production? This is the main questions that the theory of planetary boundaries is trying to answer. Planetary boundaries are the limits of the Earth system to keep the planet in conditions of stability. And if planetary boundaries are transgressed, actually the system can collapse and move away to a new stage that Will Stephan has named it as hot Earth, in which most of the planet might become uninhabitable for human civilization. Here we have, as we see, several global environmental problems in which the limits of the capacity of the Earth to absorb the impact has been transgressive, like climate change, biodiversity loss, land use change, and the effects of fertilizers. Here we can see that during the Pleistocene period, the planet was moving between glacial and interglacial periods, moving above the sea level and the average temperature in a stable situation. During the Holocene, actually, the Earth moved away to this new point, which is point B in the chart. However, if the accumulation of greenhouse gases and other transgressions of the conditions of stability of the planet are cumulative, the Earth can move away to a new long-term period named hot house Earth, in which we are not going to return to these glaciations, but we are going to keep the Earth in new conditions that are not favorable neither for life nor for the expansion of biodiversity. This is the new equilibrium named hot Earth by Stephen. And here we can see another way in which we can represent it. In the past, we have this fluctuation between glacial and interglacial periods. We moved away from it in the beginning of the Holocene, and then we can move in two opposite directions. First, accelerating the transgression of planetary boundaries, and then we can go to a new Earth system equilibrium very adverse to civilization and to biodiversity, which is the hot house Earth, or we can move to try to keep control of the situation and stabilizing the planet in a situation in which it must continue in conditions similar to those of the Holocene period. This is a very important point, but to return the planet to a situation of equilibrium similar to the Holocene requires a very, very strong change, mostly eliminating carbon dioxide emissions, protecting biodiversity, eliminating deforestation, and trying to drastically reduce the transgression of planetary boundaries. We have several examples, that's very important, in the natural history of the planet, in which the planet suddenly became extremely hot. The last one was the Paleocene-Eocene thermal maximum, which happened about 55 million years ago. As a result of massive volcanic eruptions, the planet suddenly became hotter by 5 to 8 centigrade degrees, unleashing massive extinctions and increasing sea level, ocean acidification, and other severe climatic disruptions. This period lasted about 200,000 years, which is a very, very long period of time. A similar event happened several times in the natural history of the planet, but the last one is particularly relevant because it can shed light about the future impacts on the climate, which can be quite similar to this anthropogenic induced climate change that we are observing now. Finally, I would like to present some insights about a very important point, which is the capacity of the planet to generate life and also to allow the evolution of life. Planet Earth is about 4,500 million years old. But very early in the evolution of the planet, life began. So life in the planet is 3,800 million years old. And since the beginning of life in a bacterial form in the sea, to the situation today, we have witnessed an incredible evolution. So in the long term, life becomes more diverse and complex. But we need to take into account that the Earth is the only planet in the solar system, and so far the only planet in our galaxy, able to sustain life and evolution. Life and evolution can exist only between given temperature limits, the habitable zone in a solar system. So if water is in liquid form, it allows life. If we go up to water vapor, life is not possible. And if the Earth becomes too cold, water, life is not possible. So we need to keep given limits in the climate to allow the evolution of life. But we have evidence that in spite of several catastrophic events in the natural history of the planet, the Earth has been able to keep life evolving, changing, for example, the composition of the atmosphere, creating oxygen that did not exist in the way we know it when in the origin of the Earth, creating the ozone layer and changing conditions that allow the evolution of the life. That is the Gaia hypothesis, which see the planet as a complex system which is evolving. However, this stability is not guaranteed to stay forever. We have a scientific, James Hansen, who is an expert on climate in Venus, in the planet Venus. And according with his hypothesis, actually the Earth can change dramatically in his capacity to sustain life. Here I have a quote of a book from Hansen, Storms, my grandchildren, and he says that actually if we continue burning all fossil fuels, and also if we increase the burning of shale gas and oil, there is a very high possibility that we can unleash a runaway climate change because of the liberation of methane hydrates in the polar caps, resulting in an extremely high increasing temperature that can jeopardize not only humankind, but the continuity of life in the planet. This is actually what is at stake. So climate change is not only a problem because we can face increasing disruption in the climate or catastrophic events like storms or hurricanes and so on. Actually, the problem of climate change and other environmental problems, particularly biodiversity loss, is that we are jeopardizing the future of the human civilization. We are moving away from the stability in climate in the Holocene period and creating a new geological period, which has named the Anthropocene, in which human impacts on climate and the geology of the planet might be lasting for several millennia in the future and be very adverse to the continuity of our civilization. Thank you.